Subculture or passaging. Take out the cultured T25 flask from the CO2 incubator for subculture or passaging.
This is HEK 293, this is also HEK and this is also HEK, which have been revived on 22nd. Like this one, horizontal portion, right? And the cells have been attached onto the bottom surface of the flask. They will be attached onto the bottom surface very firmly. If it is there of suspension type, two types will be there. Like for example, blood cells are there. Blood cells they will come under suspensions. They will be freely floating in the blood. In the plasma, the blood cells are floating. Like white blood cells will be there, red blood cells will be there. But they are cells only. But if you compare those cells with the muscle cell is it moving? No. They have been attached. That means they will form like a tissue. They will be connected with one another and they will form like a tissue. Like skin cells if you take. Dermal and epidermal cells are there. So all of them are like they are having a property of attachment with each other, and they will be attached onto the bottom surface, that is extracellular matrix, ECM.
Yes.
समझ में आया? So इसलिए they will be attached onto the bottom surface and they will form like a monolayer. Okay, so here you can see the morphology first of all very clearly. You have to check for contamination. If there is no contamination and all, then you can go for your routine maintenance of cells. So here there is no contamination. Cells are very proper. And here the entire bottom surface, if it is being filled with the cells completely, then we have to go for subculture. Nothing but we have to split some of the cells into the fresh medium. So that is what I am going to do now. So that naming is subculturing or else passaging. Passage. P-A-S-S-A-G-E. Passaging or else subculturing. Anything is fine. So for that purpose, what we have to do, we have to detach the cells from the bottom surface. Okay, so for detachment, we are going to use some sort of protease that is called trypsin. That means two different classes. That is subculture. How to do the procedure, I will explain you now. Clear? You can make out the gap. Laga form మధ్యలో గ్యాప్ ఉంది కదా, ఆ గ్యాప్ మళ్ళీ సెల్స్ తోటి ఫిల్ అయిపోతాయి. ఫిల్ అవ్వడం అంటే ఏంటి, ఇక్కడ ఉన్న సెల్ దిస్ సెల్ విల్ గెట్ డబుల్, second cell will be formed. From other side also that cell will get divided, will form the second one. Are you understanding? There is some space you will see. Otherwise you should not confine it to that. The flask is completely filled with cells. We have to see each and every corner of the flask. Bottom surface.
Somewhere is filled and somewhere
so we have to find out. So that is called confluency. Confluence. That is a new terminology. So that is confluence is nothing but how much amount of space is left over in the flask. So here by comparing the entire space, whatever I have seen right now, I can say that it is 90% confluent. 90% of the bottom surface is being filled with the cells. Clear? So I can say it is 90% confluent. 90% confluency is there. So 10% space is there. That 10% also the cells will get divided and they will patch up.
You just assume the thing or is there any measurement?
No measurement. Very good. There is no measurement. That is just a kind of assuming one. So we have to see it under microscope and we have to come to conclusion. That's it. There is no parameter or there is no, what do you say, checking, measure, chedanki, nothing is there. So that is with our naked eye, I mean under microscope we have to calculate.
So most of the part is filled with cells. But some part
is being left with the empty spaces. And those empty spaces also will get filled after 2 days. If you see, if you check the cells after 2 days, the entire flask is going to fill with the cells. But you know, if you keep it for 2 days more, what happens here now? The entire patch will come out.
Yes.
All the cells will get there. Okay, we should not take risk. So that's it. Whenever the flask is 90% confluent, we have to go for splitting. Got it? How to detach the cells I will show you. Now we have seen the morphology.
Yes, ma'am.
Keep the thing in your mind. After detachment, how the cells will be looking like, you have to see under microscope again. Okay? They will become round, like motichur laddus. Okay? So you are going to see them under microscope, and later on, so today we will go for detaching the cells, transfer into fresh flask, and then tomorrow if you come and see, again they will attain that shape with lots of spaces. ఎందుకంటే we are transferring half of the content into fresh flask, no? So they will get spaces, they will get space. They will divide again and they will grow. After 3 days again they will grow and they will spread, they will fill the space. Clear? So this is one of the experiment and the maintenance of cell. Okay? This is RPMI 1640, so we have to keep the things ready, right? This is phosphate buffer saline. Phosphate buffer saline. This is a buffer which we will be using it for washing. So you can see the color of this medium. This is pinkish red in color. This is because of the pH which is being maintained at 7 to 7.5. So at the biological or as physiological pH, the medium would be in red color, reddish orange. So if the pH drops down, the medium color is going to be peeled out. So here this is yellow in color because the pH has been dropped down, maybe 5 or 6. This is because of the, what do you say, cells. As the cells are growing, you know, they will take up all the nutrients which are present in the medium, and they may release some of the secondary metabolites also into the medium. So because of that, the color of the medium has been faded away. So the pH will automatically drop down. So because of that, for our identification, phenol red is going to be added to the medium. That is a pH indicator, which will help us to know at what pH the medium is, so that we can change the medium in between while doing the experiments and all. So here I am decanting the medium right now, spent medium, we will be calling it as spent medium. Then I have to wash with PBS twice. We have to be very careful. If medium is there, if you just wanted to go for subculturing, with trypsin, if medium is there, trypsin will not work. Are you understanding? So for that sake, we are removing the medium completely and then we are washing it. So now I am adding trypsin. So trypsin usually we can add in such an amount that it can spread the bottom surface. So for T25, this is called T25 flask, 250 microliters is more than enough. So what I do is I will take only 250 microliters. We have to spread it evenly. After adding trypsin, they have come out. Actually, the point is, after all adding trypsin, we have to incubate the cells. And you see what incubator? To 37 degrees centigrade. But if you take more time, all the cells will get dying, for sure. So 1 ml of medium I am adding. to stop the activity of trypsin. So now you can play with cells. So but till this time now you have to be very cautious. Otherwise all the cells will get died. So now you can see the cells under microscope. Not a problem. Patches of cells are there, right? But now no patches. All clumps will be there. You can see later also how the cells. Now patches of cells are there. So you can see later how the separation of cells will be. Take it out the next step. Apply mass pressure, cells will get die. They will break down. High number of cells are there in this one. So I can split this flask into 2 more new flasks so that I'll get more number of cells. Are you understanding? Yes. So similarly here little less number of cells are there. So I can transfer some of the amount from this flask into fresh flask. One more. Okay, so we'll do that one and show you. If incubation time is more with the trypsin, cells may get died. Right? So to check the viability, what you can do is here at this point of time, after all separating the cells completely, you can take some sample, add trypan blue and count the cells, so that you can get the number of viable cells per 1 ml. So based on that you can split into how many number of flasks you can decide. Based on that, in the sense, for example, for 1 T25 flask, you should add 2.5 into 10 to the power of 4 cells per ml.
Yes.
2.5 into 10 to the power of 4 cells per ml into 1 T25 flask. That is the seeding density. I mean, it should not be less than that, or else it should not be more than that. So approximately in that range we have to seed the cells into the flask. Ante kotta flask lo seed cheyalante anta number of amount of cells undali. So in such a way, like during this process of our journey in cell culture, we assumed, or else we hypothesized that 90% or else 100% confident flask, if you take, you can split the flask into two. In the sense, 1:1 split ratio. 1 flask into 1 more fresh flask. Got it? So that is 1:1 split ratio. So now I am doing that only. So this flask, half the amount I will take and transfer it into fresh flask. Similarly, half the amount from this into fresh flask, half the amount into fresh flask. Like that I will go for 1:1 split ratio right now. So as I've been already done with the trypan blue counting previously, now I am not making you people to do that one. Okay, so you can see to it later. So now I am doing it directly without going for any checking the number of viable cells. Okay, got it? So now I will transfer half the amount. For that sake, first of all, we should wet the new flask. media should be there in a T25 flask. So now I have added 4 ml of fresh media into new flask, and from the previous flask I will be taking 500 microliters into this one. So that would be 4.5. That is okay. 4.5 to 5 is okay. So it should not be lesser than that amount, or else it should not be higher than 5 ml. So around 5 ml is okay. So now what I do is I will transfer 500 microliters from each flask and transfer it into the fresh flask. Okay, got it? 1 ml plus already 250 microliters of that will be there. Trypsin will be there. We are not removing the trypsin, I think, if you observe. So trypsin 250 microliters I have added, and then immediately to stop the activity of trypsin I have added 1 ml of media. So that nominal amount of trypsin will not do any problem. So if you feel like trypsin is causing some sort of problem during the process of your research work and all, I'll take little more. Okay. While taking the inoculum or else the cells, we should mix it properly. Otherwise all the cells will get settled down. They will get sedimented. So now what I have to write is search. This is SE4, that is subculture 4. So now I have done subculturing, right? So SE5. Today's date is 27. What is the difference? On 22nd we have seeded the cells. Today is 27th. So 5 days. Within a span of 5 days, the entire flask is no, SE4 is done. Now SE5 is done. So 27, 6, 23. HEK. This is, I can say it as master bank 2 in B, represents master bank. So this is 25, 27, 6, 23. Now altogether 6 are there. So if you see the cells, very less number of cells will be there which are round in shape now. They will be round in shape. So tomorrow if you see, they will be, if they are healthy, they will definitely attain their shape. Like in the morning, in the beginning, how you have seen the cells. Similarly, you may see the cells like in detail cells in the first panel. Now you have seen, no, with less number of cells, you can see the class with the even distribution. You can see the cells.